Program button. I'm going to list program. I'm going to go over to USB device. I'm going to find it. Mine is 2003. I'm going to do select program. If I press enter, it wants to basically go in that file, which is not really what we want. So instead, go over to it and hit select program. There we go. You'll see it show up. We can switch to memory to make sure it's loaded. It should be white. Once it's loaded in memory and we are in memory mode, that button will start your program. You can see also here all your tools. So you got six tools. You want to make sure those tool numbers are correct with what you put in the machine. Since this is the first time I'm running this part and I don't know who programmed it, I'm going to switch over to 5% rapid. What this is going to do, if I'm at 100 and I start this program, that machine moves at full speed. I don't want that. So I'm going to let it switch tools first. And then switch to 5% rapid. You're going to see it's going to move really, really slowly. So it's already in the program, but this is a lot more controlled. Anytime I need to check something, that is the magic pause button. Pretty much always safe, even relatively in a cut, to pause it. If you want to check something, if you want to, check your tool, double check anything at all, check your Mastercam, pause it, unpause it as many times as you want. That is your best friend. Use it. What I want to do is right now our position is showing the machine position. I don't really care about that. So what I'm going to do is press position on display and switch it over to distance to go. This is going to show you what is that tool about to do next. Got to move 2 inches to the right on the X. If I press cycle start, it's moving 2 inches. Spindle turned on, and it's going to start moving down. So I'm going to pause it right there and check. It says it's going to go down 3 1/4 inches on the Z. That looks about right. If that tool is right there and that says -10 inches, something's wrong. That means your tool is about to go 7 inches below your vise, and that's not good. At that point, you don't want to reset, check your probe, check your program, something's wrong. But that looks pretty good, so I'm going to continue at 5%.
His finger's on that red button in case he needs to push it.
I'm always on that, because anytime, if that tool breaks or something's wrong, it takes 1/4 of a second to just pause it and double check it. So everything still looks good. You're going to see as that tool gets down to that feed plane, it's going to be throwing a ton of coolant. It does make it hard to see, so if you're ever paused, there is a coolant button that you can press to just turn it off if you want to check it. Just make sure you turn it back on before you continue running. Another thing is if you don't trust your feed and speed, you can override the feed to be a little bit slower. I tend to always, just on that first cut, default to 50%. So that if something is catastrophically wrong, the chance of my tool breaking immediately is a lot less. As I kind of hear it, as it starts to cut, I'll kind of bring it up if I trust it. I'm going to start at 50. It's going to start spiraling into my part. And you might hear it. It's a very, very light cut. It is currently cutting. However, when it was programmed with a very, very small pass.
Yeah, we got
could probably go a little deeper than that.
Okay.
All right, this is barely shaking. You can actually feel the vibrations when it's cutting on the machine. And so I can definitely bring my feed rate back up to 100. You can see it's cutting out that pocket.
Is that amount of coolant necessary?
Better to have more than not enough.
It recycles.
Yeah.
Isn't it more for like the tool life than for your
It's a combination of extending your tool life, getting a better surface finish, and also keeping tolerances, because if your part is heating up, that's going to expand or contract, and your tolerances are not going to be as accurate. So it's kind of just a best of every world, especially with metals. You pretty much always want coolant.
It's not like expensive to, like you said, it's like mostly water.
It's recycling it.
Okay. Yeah.
So there's no new water. It's continuously filtering it out through the back over there. You can see it.
Oh.
Sometimes the water does evaporate, so you can see it's got pretty good pressure. If it looks pretty low, find one of us, we'll throw some more deionized water in there.
Because Aiden did a part on Friday, like, didn't have any coolant on purpose, so I don't know.
So he was using wrenching, which is kind of a plastic or wax. On some of those, you don't really want coolant. Yeah.
It wasn't metal.
So we've got like blue wax blocks that we don't run coolant. It doesn't need it. It makes more of a mess, and it's just not necessary.
Yeah.
On metals, however, definitely would recommend it.
I forgot it was plastic.
I mean, it cuts everything just a lot easier too. You know, it's like throwing coolant on the manual mill, but you've got a lot more. I mean, keeping your part and your tool especially cool just helps with everything. It's just better in every way. So when you set your feeds and speeds, they should match here. So you can see the current spindle RPM, spindle load, including the percentage, pretty low. Our surface feed, which I set about 200 for aluminum, that's pretty low. Aluminum, for depending on the tool, can be 200 to 400. Some carbides can go 700, 800. Look it up, there's charts.
Yeah, we got all those charts. So you notice that tool load is way low.
Yeah.
The spindle load is like force on the spindle or something, or what is it?
Yeah, so it's the load on the actual spindle motor.
Okay. Oh, like resistance that it's getting? Okay.
Yeah, right, because that cutter is basically pushing into that metal, and there's going to be some forces coming back that motor is fighting against. It usually doesn't go very high unless you're cutting, you know, maybe titanium. You might see that go up to 40% or something. But aluminum, even steel, it's going to be pretty low.
If I increase the depth of cut, then it would...
You'll probably see it a little more.
These are pretty...
And then you can see our feed rate as well as our active feed rate. This machine doesn't have it, but on the newer software on the VF3, it'll actually have some colors to kind of show you green is about 0 to 60.
Like you said, it's like most stuff we do here shouldn't get it that high, right?
Can you tell what... Is that the same tool?
That's the counterbore right now.
Oh, it's
So that sound is actually basically flat drilling counterbore. Sounded like it did it. We'll see how it looks after. That's the tool I was kind of more worried about. I've never used a counterbore tool. Anytime I counterbore something, I drill it and then I take an end mill that's the same size or smaller and just circle mill. Because almost always I don't have a counterbore, but I almost have a small end mill that I can just mill it with, and that's worked pretty well for me.
So if you're making 1,000 parts, it'd be a lot better than using a counterbore tool.
Because that counterbore tool, you can probably send that a lot faster than a small end mill. Especially on small drills like this. This is a bit of a tougher one. We've got the smallest drill possible. I believe it's a 1/16th drill. I'm also a little bit worried about this one.
That tool change is so cool.
So you're going to hear that thing ramp up. This is such a small tool, so it wants to spin faster. We're currently at the max RPM of the machine, which is 8,000. If you look up the recommended feed and speed for this tool, it's probably about 15,000 RPM, but these machines just cannot go that high, so go to the highest RPM you can and adjust your feed to that. So it probably wants to send this at double the RPM and double the feed. We can't do that, so I'm going to send it at the max RPM and half the feed.
If the code says 10,000 RPM, it doesn't error out,
it's just going to max it. Mastercam will let you do 50,000, so that's going to stop at 8. So that's a problem if you're wanting it to be a lot higher.
You see what I'm doing, that peck drill? I'm going down, coming back up, going down, coming back up. Yep.
Yep. So in the drill toolpath for Mastercam, you can change the kind of cycle it is. And it'll go from just a drill or counterbore cycle to a peck cycle. And you just tell it how much to peck each time.
You're going down at 5% every time? 25%?
Just 25. I usually do 25 or 50 for the first couple. Just because 5% it's a little slow, but 25 is reasonable enough where you could stop it before it could crash into something. I wish there was like a 15%, something in between.
Oh, you can't dial that in. It's either whatever the button says.
You can dial in the feed and speed overrides, you cannot dial in the rapid. So if I wanted to very finely control the feed, you can hit handle control feed and actually use the dial to get down to 1%. For the rapid, no. it's either 150, 25, or
Oh, so those buttons are just for the rapid use.
Does it matter that tool's got metal shafts all over it?
not really. It'll take it up with you. If you're doing a lot of parts, you might want to clean them, you know, after a few. I mean, I've had half-inch drills that there's a ball that chips around it. It's fine. What you can do is if you've got a deep hole though, those chips are going to basically kind of mar up your surface.
Anything that needs to be shiny, just
But in general, not really, unless there's just excessive chips. You definitely want to clean them off. Like you see, it's got a little bit. The drills are going to catch onto those quite a bit. That's the program. As soon as that goes flashing green, that either means it's on a pause or at the end of the program, but we can see we're back to the start. So that's our part. Simple.